Hello guys, today we are going to study properties of continuous function. This is part 25.8 of NIOS. It is properties of continuous function. The first point we need to understand is that in general all constant functions are continuous. If a function is continuous, then the constant multiple of the function is also continuous. Example, let us consider the function f of x is equal to 7 by 2x. Here x is a constant function and let a be an arbitrary function. Limit x tends to a, f of x equals f limit h tends to 0, f of a plus h. This is equal to 7 by 2 a plus h, let h tends to 0, which is equal to 7 by 2. Limit x tends to a, f of x equals f of a. So f of x is equal to 7 by 2x. So we can say the function is continuous. Let us move to example number 2. Let us move to example number 2. Consider the function f of x is equal to x squared plus 2x. We know that x squared and 2x are continuous. Now, limit x tends to a, f of x equals limit h tends to 0, f of a plus h. This is equal to limit h tends to 0 a plus h whole squared plus 2 into a plus h, which gives us limit h tends to 0 a squared plus h squared plus 2h plus 2a plus 2h. Applying the limits, we get a squared plus 0 0 and 2a. We get this. And also we know that f of a is equal to a squared plus 2. Let us consider this as 1 and this as 2. From 1 and 2 we can say that limit x tends to a f of x is equal to f of a. So we can say that the f of x is continuous at x is equal to a. Consider the function f of x is equal to x square plus 1 into x plus 2. F of x is equal to x squared plus 1 into x plus 2. If we multiply this, we get it as x squared plus 2x squared plus x plus 2. As we know that x cube, 2x cube, x square and 2 are all continuous function, we can say the function f of x is also a continuous function. We can say x cube plus 2x square plus x plus 2 is also a continuous function. Let us move to example number 4. Consider the function f of x is equal to x square minus 4 by x plus 2 at x equals to. We know that x square minus 4 is continuous at x is equal to and x plus 2 is also continuous at x plus 2. So first we'll write limit x tends to 2 x squared minus 4 by x plus 2 is equal to f of 2. Okay, we'll prove this. If this is correct, then we can say the function is continuous. Okay, we'll do it in the next page. So limit x tends to 2 x square minus 4 by x plus 2 is equal to limit x tends to 2 x plus 2 into x minus 2 by x plus 2. Cancel x plus 2 from here. We get limit x tends to 2 x minus 2, which is equal to 0. Similarly, we can write f of 2 is equal to 2 square minus 4 by 2 plus 2, which is equal to 0. From 1 and 2, we can say limit x tends to f of x is equal to f of. So we can say the f of x is continuous at x equals to. This is so we can say that if x square minus 4 by x plus 2, in this case if x square minus 4 and x plus 2 are continuous at x equal to 2, we can say x square minus 4 by x plus 2 is also continuous. My mission is to completely cover NIOS syllabus in this. What I have seen in many videos is that most of them doesn't cover the entire syllabus of NIOS public exam. So I want to teach you everything in the way I can. Okay. So let us move to example number 5. I hope you are all covering it in your notes because notes are compulsory. Otherwise, just watching it will not help you in effectively. Consider the function f of x is equal to mod x minus 2. This function can be written as x minus 2 if x is greater than 0 and if x is greater than equal to 2 and minus of x minus 2 if x is less than or equal to 2. Limit x tends to 2 minus f of x equals limit h tends to 0 f of 2 minus h for h greater than 0. Applying this, we get f of limit h tends to 0 2 minus h minus 2, which gives us the value of 2 minus h minus 2. Here h and 2 and 2 will get cancelled and h will be left over, so we get the value as 0. Similarly, limit x tends to 2 plus f of x is equal to limit h tends to 0 f of 2 plus h, which for h greater than 0. We can write this as limit x tends to 2 plus h minus 2, which gives us the value of 2 minus 2, which is equal to 0. And f of 2 is equal to 2 minus 2, which is also equal to 0. From 1, 2 and 3, we can say that limit x tends to 2 f of x equals f of 2. Therefore we can say mod x minus 2 is continuous at x equals 2. After considering the above results, we state below some properties of continuous functions. If f of x and g of x are two functions which are continuous at point x is equal to a, then we can say c into f of x is also continuous. F of x plus g of x is also continuous. F of x into g of x is also continuous. F of x divided by g of x is also continuous, and mod of f of x is also continuous at x equals a. This is very important. So if a function f of x and g of x are there, then we can say that c into f of x is also continuous, f of x plus g of x is also continuous, f of x into g of x is also continuous, f of x divided by g of x is also continuous, and mod of f of x is also continuous. So these are the properties which we need to by heart for example. Note it down or take a screenshot. Along with the properties which we have just studied, we have two results which are based on these properties, which are first properties no sorry results based on which are first one, every polynomial functions are continuous if f of x is equal to p of x by q of x and p of x and q of x are polynomial functions. We can say that f of x is also continuous. So these are the two properties which we have to study with the results. Okay, thank you, that is all. Now in the next video we will talk about the examples 25.21, 2021, 22, 24. Okay, thank you guys.